Hello guys, welcome back to my channel. This is a day second of our crash course and today we are starting with periodic classification of elements. Today we are starting with the periodic classification of elements and I hope every concept which are there according to your exam point of view, I'll be clearing that in a very simple and easy way. Okay, so without wasting any time, let's get started. So, periodic classification of elements. So how many elements can you name so far? There are so many elements that are surrounding you. In everything which you see is made up of some kind of matter, and there are some type of elements which you see. You cannot see the element obviously, but there are some kind of elements which are there around you. So comment down the elements which you guys know, and how many elements can you name so far? As you can see here, I have taken out some pictures in which you can see the elements out of which these things are made up of. So today you'll be able to learn elements and their classification, Dobereiner triads, Newlands Law of Octaves, Mendeleev periodic table, and modern periodic table. So these are very much important concept of this topic. We'll start with the basic topics, with the basic concepts, and then we'll move on to the advanced concept of this chapter. So starting with the elements and their classification. Starting with the elements and their classification. So classification of the element. What is a classification? Now, what does the word classification means? When I say that I am classifying the elements into the groups. So what does it mean? That classification of elements means arranging the elements in the systematic manner, arranging the elements in a systematic manner so that the elements with the similar properties are placed together. So, whenever I am arranging the similar properties, whenever I am arranging the chemical elements or the elements which are of the similar property in the same place, that means I am classifying them. And this is nothing but a classification of elements. Then why do we need a classification? Why someone needs to classify these elements into a certain groups? So a large number of elements exist. We know that there are 100,000 number of the elements which are there in our surroundings and the universe. So, and for studying them, each one separately is very much difficult, is quite difficult and confusing. So we cannot study each and every elements as an individual. So it's very important that if I see some similarities between the chemical elements, between the elements, so I can group them together so that it will be easy to understand them and to study them. So many elements show the similar chemical properties and physical properties as well. So what does the classification helps? How does it will help? How it will help? It will make study elements easy, predict the properties of unknown elements. So if I have grouped together certain numbers of elements, so I know what are the properties they shared. And if there is something which is unknown element, so I can place it at the another group. So it will also help me to predict the properties that it won't be similar to the properties of the element that I already know. So classification will help me to study the element easily, will study the element easily. It will help me to predict properly of the unknown elements and understanding the relationship between the one group and the another group. So what are the similarities, what properties are linking between this different groups of the elements? So classification will help me into this. Okay, now on what basis will be the classification has done? On what basis has this classification done? So initially scientists tried to classify the element on the basis of their atomic masses. On the basis of their atomic masses, their the chemical properties which are there in this element, in between the different groups of the element. Then there is certain physical properties, and these attempts led to the development of early periodic laws. Okay, now what does the term atomic mass means? There's a new no, I hope this is not a new term for you all, but just in case of revision, let me tell you, atomic number is a combined mass of protons, neutrons, and electrons as well. Okay, this atomic mass is the combined mass, okay, of any element, where in which the it will be the combined mass of protons, neutrons, and electrons. And let me also tell you that protons are the positively charged, electrons are the negatively charged particle, and the neutrons are neutral. It means they won't have any positive or negative charge on them. And when I'm talking about their combined mass, it will tell me what? It will tell me the atomic mass of that element. Okay, so that was the case on which the classification has been done in the earlier periods. Okay. Okay, I hope the classification, this was a very easy topic, and if it comes, you can write it in a very proper manner. Okay, so starting with the Dobereiner triad. This is also a very important topic, and it can also come to classify the triads or to solve out the Dobereiner triads. So starting with the Dobereiner triads, what are the Dobereiner triads? Dobereiner grouped the element into these sets of three, which he called as triads. Okay, so whenever I'm placing certain elements in a group of three, whenever I'm placing something in a group of three, so Dobereiner called it what? Dobereiner called it as the triad. Okay, and into which this chemicals, all these three chemicals had the same chemical properties. Okay, and the atomic mass of the okay, so this is a very important part. The atomic mass of the middle element, the atomic mass of the middle element was approximately the average of other two. Okay, so the first point which we'll be learning about this, that the Dobereiner has grouped the elements into the sets of three, which he called as the triads, and all these three elements share the same similar chemical properties. And the next point is that the atomic mass of the middle element was approximately the average of other two. And for just as example, he has also given a certain example. You can also put it into your answers. Example of Dobereiner triad, he has taken lithium, sodium, and potassium. Now the lithium is the atomic mass, which is 7. Okay, and the potassium, which is 23, and similarly the sodium, which is 23, and potassium, which is 39. And for the average of lithium and calcium, I hope you guys know how to calculate the average. Just in case you don't know, let's see how do we calculate the average. Okay, so the sum of first and the last term, which is 7 plus 39, which is 7 plus 39, which is 7 plus 39. And for the further average, I'll have the sum of this number, which will be 7 plus 39 will be 46. And when I divide 46 by 2, okay, the formula for the average was the sum of the observations upon the number of the observation. So similarly here, 7 plus 39 will give me 46 divided by 2, because there were only two numbers. So the number of observations were 2, and that will give me what? 23. When I divide 46 by 23, that will give me 23. So 23 here was the sum of what? 23 here was the sum of, was the atomic mass of 23. Okay, now another example here again, which was calcium, strontium, and barium. Now calcium is the atomic mass of the atomic mass, which is 40, and the barium, which is 137, and barium, which is 137. And when I calculate, when I get the sum of this number, what will I get? I'll get 177. And when I divide 177 by 2, when I'll divide 177 divided by 2, I'll get what? 88.5, which is approximate or somewhat near to this the atomic mass of the strontium, which is 88. So average mass of calcium and barium, which is 88, it is the atomic mass. So this was how Dobereiner put the numbers into the sets of 3, puts the element into the sets of 3, and told that this share the chemical properties, similar chemical properties, and the average of first and the last term will be the atomic mass of the second one. Not the exact, but approximate. But let's see how, what were the merits and demerits of this. Okay, now merits of Dobereiner triads and limitations of Dobereiner triads. So he was the first one who successfully attempted to relate with the atomic mass with the properties. It means he was the first one who has tried to relate what was the atomic mass, and he has related that term to the with the elements, and shows that properties of elements are related. He was the first one who shows that, who has shown that there are some chemical properties and there are some physical properties which are similar with the other elements. This was the merit of Dobereiner triads, whereas there were also some limitations of the Dobereiner triad. So only because he was the first one who has successfully attempted to relate, but only few numbers of element could be fit into this triads, and most known elements did not fit into the system. Of course, there were not the large number of elements that were known at that time, but most known elements, even of that time, couldn't fit into the system. Hence, this system was not universally applicable, and these were the limitations of Dobereiner triads. Though he has shown that there are some properties which the chemical shares, which the element shared, but only few elements could fix into this average system and this Dobereiner triad system, and not every element could fit into the system. That was the reason that this Dobereiner triad was not universally applicable. Okay, so moving on with the next concept, which is Newlands Law of Octaves. Now, what does the Newlands Law of Octaves says? That when elements are arranged into the increasing order of their atomic masses, the properties of every eighth element are similar to that of the first. Now, as the Dobereiner has put the elements into the sets of 3, the Newlands octaves have put the elements into the sets of 8, in which he has shown that the chemical properties of the first one will be similar to the chemical properties of the eighth element. Okay, now Newlands notice a repetition of the property after every eighth element. So similar elements or similar chemical properties appeared at the regular interval. Similarly, he has given us the example, which is lithium, sodium, and potassium. Okay, lithium, sodium, potassium, the similar elements which Dobereiner had put into the triads. Now, Octave had got the new way of shown the similarity between them. He has shown that every first and the eighth element when they are put into the sets of 8, the set of the first element in the set of 8 will show the similar property as that of the eighth one. And again we can say that see that there is a difference of 8 between the 8 and 15, including 8 and 15 both. Will keep that in the mind, that we do not have to exclude 8 in the group of 8. Like we cannot start from 9 to 15. Okay, that gives me only the 7 elements in between, but I have to include 8 as well and 15 as well. Okay, so I have to include them both. And there were some there were some similar properties between lithium and sodium. Similarly, sodium and potassium also show these similar chemical properties. So that was the way how the octave has classified all the elements into the sets of 8. So again, the merits of the Newlands law of octaves. Newlands octaves, we can remember it from the octane and octaves. Like octane is 8 and octaves has also put the elements into the group of 7. So octane and octaves, and triads and 3, we can also remember it. So that can help as a mnemonic for you guys. So now the merits of Newland's octave, that he has recognized periodicity in the properties. What does it mean by the periodicity? That after a regular interval, after some time interval, chemicals will show the similar property. Okay, chemical will show the similar property. So he has recognized some periodicity, that after regular period and after a regular time interval, the elements will show the similar property. So he has arranged the elements systematically. He has arranged them systematically according to their number. He has given them a proper number, and with the proper systematically with the atomic masses. And it worked well for the lighter elements. Okay, he hasn't given anything about the higher elements, but the Newlands law of octave worked well for the lighter elements. Now, what were the demerits of the Newlands octave? It was only valid up to the calcium which was 40. Calcium which has an atomic mass of 40, it worked only well up to the calcium. And um, he assumed that only 56 element existed, though the new elements were discovering and will be were discovering at the time. But he assumed that only 56 elements are there, and there were no place for the newly discovered elements in his uh, Newland's law of octaves, in his law. And sometimes he placed two positions. He placed the two different element into the one position. So that was also a demerit, that it was also not applicable for all of the elements. Okay. Similarly, when we move further, we have the new laws, which is Mendeleev's periodic law. Now let's see what does the Mendeleev has to say about the elements and their position and their functions. So, statement of the Mendeleev periodic law: the physical and the chemical properties of the elements are the periodic function of their atomic masses. Now, he doesn't have to say that it will be similar after the 3 or the 8 numbers, and he hasn't put that elements into the sets of 3 or the sets of 8. But he said that when elements are arranged in an increasing order of their atomic masses, their properties repeat after the regular interval. The properties repeat after the regular interval. He says that whenever we are arranging the elements into the increasing order of their atomic masses, then their properties will repeat after the regular interval. He hasn't specified at what interval, but he has shown that it will be repeating after some time period. Okay, now Mendeleev has classified on some certain basis. Let's see what was this basis was. Okay, so before moving on to the basis of classification, let's just see how and who was the Mendeleev. So in 1869, a Russian scientist who was a Dmitry Mendeleev produced one of the first practical periodic table. Before him, no one has tried to make this periodic table. Though some certain scientists have tried to classify the elements on basis of some properties, but he was the first one who produced the first practical periodic table. His work laid the foundation of modern periodic table. So he was the first one who has classified the elements on the proper scientific and systematic manner, and he it helped to lay the foundation, and he laid the foundation on which the modern periodic table has been made. Okay, and the most amazing part uh, is that table of elements left spaces for yet to be discovered elements. Now we can see that he has given some different names for the, he has left the gaps in his table to which, for which the predicted name he has given. Okay, like for the gallium, he has given the name Ica aluminum, and for the germanium, he has given the name for like as Ica silicon. So we can see it further. I'll tell it further. I'll show it further. So no one has done that before. So that's why that was the amazing part which has been done by the Mendeleev in his periodic table. Okay, now basis of basis of the Mendeleev's classification. So Mendeleev classified the element on the basis of atomic masses, similarity in the chemical property, the valency, and the formation of similar compounds. Now we can see that the Mendeleev has also done the classification on the basis of the atomic mass and the properties which he has seen similar in between the different chemicals, and he has also classified the elements on the basis of their valency. What does the term valency means? I hope you remember it. The number which are there in the outermost shell or the outermost orbit of an element, with which he not share, but gain and lose and complete his octet to be stable, and that was the valency. So the Mendeleev has derived this new term here. Because before that no one has talked about the valency, and he has also classified the element on the basis of formation of similar compounds. Okay, that this several elements form this similar compounds. So on the basis of that he has classified the elements. Now Mendeleev periodic table has some certain structure and basic structure. So vertical groups, so he has named this vertical columns as the groups. Okay, so these were the vertical columns which he named as a groups, and there were some horizontal rows in this in his laws and in his table, which he called as the periods. So the vertical column were the groups, and the horizontal rows were called as the periods. Okay, key points of the Mendeleev periodic table. He has put some similar element placed together which shows the some chemical property and had the same valency, same valent electrons in their outermost shell. Then he has left the some gaps for the prediction of undiscovered element, like the prediction of undiscovered elements were. He has the given the name for a name as the ecaluminium, and today we know the aluminium as the gallium. So whatever elements weren't discovered at that time, he has given the name for them, and he has also left some spaces in his periodic table for these elements, like ecasilicon and ecaboron. So ecaboron is also known as scandium now these days, and ecasilicon is known as germanium. Okay, so he doesn't claim that there any other um, that this number only existed. Okay, so he has left these spaces in his periodic table for the undiscovered elements. And correction of the atomic masses. Some atomic masses were corrected based on the chemical properties. Example, gold and platinum. Let me just clear this. Okay, so he has also corrected the atomic masses on the basis of their chemical properties. Now, Mendeleev periodic table, he has classified the group into the eight groups and eight columns that were the 1, 2, 3, 4, 1 to 8, and he has certain periods like periods that were the period 1, 2, 3, 4. So he has put the hydrogen, the first element in the period 1 and group 1. Then in the period 2, there were the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And similarly, there were some certain elements. So he has classified not till only to the calcium, but he has some certain more elements put together in his periodic table. So this was the structure of the Mendeleev's periodic table. Now, achievements, merits of the Mendeleev periodic table. What were the major merits? Let's just see that. So he was the first one who has systematically and scientifically classified the elements into the groups. And he has also discovering the new elements. He has helped into discovering the new elements, showed the periodicity in the properties that after some regular interval, the chemical properties of these elements will start reoccurring or they will show the similarity. And he laid the foundation, the basis on which the modern periodic table has been made. So these were the major merits. This is also very important from the exam perspective. This question has been asked most frequently. Now, limitations of periodic table. What were the limitations? He couldn't place the hydrogen property because uh, shows the property of alkali metals. I mean, he hasn't placed or shows the property or had shown the property of the hydrogen very clearly, because sometimes he had placed it into the alkali metal, which was a group 1, and sometimes into the place he placed it into the group of halogens, which is also called as inert gases. So there was not any fixed position for the hydrogen in Mendeleev's periodic table. Okay. Then similarly, we have the isotopes. What are the isotopes? Which the elements which show the same chemical property, but these elements have the different atomic masses. So, since the Mendeleev periodic table was based on the atomic masses, he couldn't explain the isotopes. Isotopes hasn't been explained in his Mendeleev's periodic table, and it was though it was later discovered, but he hasn't said anything about this isotopes. So this was also the demerits of the. So since he has shown some certain merits and the achievements which hasn't the previous scientist has shown, but he has also some demerits as well. Let's see the other demerits of Mendeleev periodic table. The and एक minute. Okay. So what were the other demerits for the Mendeleev's periodic table? These were the anomalous pairs. What does it mean? That some elements violated the atomic mass order. They weren't placed according to their increasing atomic mass number. Similar, as example given here, like cobalt has placed before the nickel, and similarly tellurium placed before the iodine. So these were some example of the elements which were not following the increasing atomic mass number, and this was also the So these elements are called as anomalous pairs, which weren't following the increasing atomic mass number. Similarly, he has left certain gaps for the new elements or new undiscovered elements, but he hasn't placed properly for the noble gases, which discovered sometime later. And in the periodic table, we have this different place for these lanthanides and actinides, which the Mendeleev periodic table hasn't shown. Okay, so these were some demerits regarding the Mendeleev periodic table. I hope it's clear. Okay, now modern periodic table and modern periodic law. The physical and the uh, chemical properties of the elements are periodic function of their atomic masses. Now, a drastic change here we can see here, because before this, every laws and every table which has been made was based upon the atomic masses. But here, the modern periodic law and modern periodic table says that the physical and the chemical properties of elements are the periodic function of their atomic number. So this is based on their atomic number and not on the atomic masses. Okay, so atomic number is more important than the atomic masses. Now, what was the need for the periodic law? Since the Mendeleev has made certain merits as well, and demerits were also there in the Mendeleev periodic law, so there was not any isotopes placed in his periodic table, and atomic mass anomalies like we have seen that cobalt and nickel, okay, and tellurium and iodine. So these were the atomic masses anomalies which were not placed according to the increasing order, and there was not any unclear position, and there wasn't any clear position for hydrogen. Sometime he was placed in the group 1 and sometime he was placed in the group 8. Okay, so these were some these were some limitations which we have seen in the Mendeleev periodic table. So this was the need for the modern periodic law, and he also doesn't have some proper place for the newly discovered elements. Therefore, there was a need to uh, make a modern periodic law. And modern periodic law, discovery of the atomic number, okay, discovery of the atomic number. Henry Moseley proved Henry Moseley was the first one who has discovered the atomic number and show that atomic number, which is symbolized by Z, he shown that it is more fundamental and more important than the atomic masses and its property. Atomic number, how does we calculate it? This property depends upon the number of the protons. Again, the protons which are positively charged. So he has shown that these properties depend upon the properties of the atomic numbers are dependent upon the protons and not the fundamentally the whole mass, which was based on protons, neutrons and electrons. Okay, and that was how we calculated the atomic masses. But here Henry Moseley shows that had shown that the atomic number is more fundamental property than the atomic mass, and on the basis of that he has defined the atomic number. Now, key features of the modern periodic table. When elements are arranged in the increasing order, their order of the atomic number, their properties repeat periodically, and periodically is repeat of the similar electronic configuration. It means that when we arrange the elements into their increasing order, after some time we'll see that due to the similar electronic configuration, similar chemical properties, similar structure, the elements will start showing the similar properties and will start repeating again. Okay, now what were the basic features again? This modern periodic table has 18 group, and this was similar, something similar which we had also seen in the Mendeleev's periodic table. So this the basic feature of the modern periodic table was there was 18 group, which we called as a vertical columns, and it has the 7 periods which were the horizontal rows. and the elements are arranged according to their increasing atomic number. This is a very important point, and because the elements here weren't distributed or were not arranged on the basis of their atomic masses. Now here are some periods which are there in the modern periodic table. Periodic number significance, period number are the number of shells, and as the group increases, atomic number or atomic size increases. Okay, so how does the atom are classified, or the atomic numbers are given in the modern periodic table? These elements in the same group have same valence electron. They show the same chemical properties, and so that's why, that's the reason that they were placed into the same similar group. Then group number and valence electron, like group 1 and group 2 have the same number of valence electron. That's why they are grouped in that's why they were grouped into the similar. Now here are some basic and structural of the modern periodic table. Let's see how the elements are placed in the modern periodic table. So there are 118 elements in the modern periodic table, and all the elements are arranged according to their increasing atomic number. Please keep in mind this atomic these elements are not placed according to their increasing atomic masses, but the atomic number, which are the number of protons present in the elements, and each box contains the one number of elements. So this is modern periodic table, as you guys know, and each one of the elements has a different place in the different boxes. So each elements had the different position in the periodic table. Similarly, the periodic table has a period. So period is a row on the modern periodic table which runs horizontally and not vertically. So period is the horizontal uh, line on the modern periodic table, and there are these 7 periods in the modern periodic table. Okay, similarly, there are some more about the periods. The 2 rows below the periodic table are lanthanides and actinides. Collectively they are called as inner transition metal, and lanthanides are also called as a rare earth elements, where actinides include most artificial element with a few exceptions. So when I say lanthanides, these are some elements which are present naturally on the earth, and since they are very much rare, okay, so they has given the different name which is called as lanthanide, and they are placed apart from the periodic table, not very much apart, but they have a unique place in the modern periodic table. Similarly, actinides are also placed with the lanthanides, and actinides mostly are the artificial elements with the few exceptions. So these lanthanides and actinides are called as inner transitions metal. Okay, and they have a different place in the periodic table. Okay, now moving away or moving apart from the periods, we have a group in a periodic table. So group is a column of a tables. Columns run vertically. Please keep in mind, don't be confused in the what is in between what is period and what is group. Period was the horizontal line, and the group are the vertical line. So group is a column of the table, and columns run vertically. So there are 18 groups in the modern periodic table. Group 3 to 12. Okay. Now group 3 to 12 are called as are labeled as transition metal, which is referred to as the D blocks. Okay. There are 18 groups in the modern periodic table. Okay. There are 18 groups in modern periodic table, and group 3 to 12. This year we have group 3 to 12. These 3 to 12 groups are called as the elements which are present in the 3 to 12 groups. They are called as transition metal. Okay, they are called as transition metal, or we can refer to it as D block elements. Okay, these are referred to as the D block elements. Now, some more information about the group. The numbering 1 to 18 established by the IUPAC, but most modern periodic table use the conventional Roman numeral. Later combination, that is group 1, is also labeled as IA. Since it is not much of more importance from a perspective of exam, but this is just important to know. Okay, like group 312 belongs to the group B, while group 1 2 belongs to the 13 and 18. I mean, the numbering has been established by the IUPAC, but the modern names or the modern periodic table use the conventional Roman number plus later combination. It means it will also have a group 1, and the it will also have a later combination. It means there is a number and a later as well. Like 3 to 12 belong to the group B, while groups 1 to 2, 1 and 2, 1 to 2 belongs and 13 and 18 belong to the group A, which are called as the representative elements, which will be called as representative elements. Moving forward, how the metals and non-metals are put into the modern periodic table. So metals, as we know, these are the good conductor of electricity. As we know that these are the good conductor of electricity, and the thermal energy, high density. They have the high density. They are the malleable. What does the word malleable means? Which means they can be drawn into a thin sheet. Okay. Also, they have a ductility. What does the word ductility means? They are sonorous, they are ductile, and they have a malleability. So the word ductile means they can be drawn into the wires as well. Okay, this is the ductility, that they can be drawn into the wires. Okay, and they have high melting point. Yes, okay, they have a high melting point. They are sonorous, they are lustrous, and how they are placed into the modern periodic table. So all these green boxes which you see in my cute and very much clear presentation. So these all boxes which are green in color are the metals, okay, in the modern periodic table. So this is metals. So this is how metals are placed in the modern periodic table. Similarly, non-metals. Now, how does the non-metals are placed? So all these purple boxes, let's just see what are the properties of non-metals. They are poor conductor of electricity. They are poor conductor of thermal energy. They have a low density. They are brittle. They can be break down into the powdered form. They have the low melting point. They are non-malleable. They are non-ductile. They are non-sonorous. Okay, lustrous means they do not shine. Non-sonorous, they could not produce these sounds. Okay. So now how the metals are placed? All these purple boxes, hydrogen and helium. So these all are the non-metals. Okay. So this purple boxes here. So these all are non-metals. Apart from this, large numbers of metals. Moving forward. So, how are the elements in the LO collectivity? Now, we have seen that this. Now we have seen how metals and non-metals are present in the modern periodic table. This green were the metals and this purple were the non-metals. But what about this LO elements, which are collectively present in between the metals and the non-metals? Okay, so what are these elements? If you guys know, please comment it down. And if you do not know, let's just see what are these elements. These are metalloids. Okay, these are the metalloids. The property of metalloids can be similar to metals and non-metals. When any element show the properties of both metals and non-metals as well, they are called as metalloids. They are called as what? Metalloids. They appear to be more likely to be non-metal but conduct electricity. It means they have the properties of both. So they are also called as semiconductors. They are also called as semiconductors. Okay. So all these yellow boxes which you see here, these are the these are what? These are the metalloids, which have the properties of both um, which have the properties of both metals and non-metals as well. Moving forward, let's move on to the periodic trends which we see in the modern periodic table. So now periodic trends are repeating found in the modern periodic table as you move across to the periods or down a group. When you move across a period from left to right or down a group from top to bottom, what changes do you see here? One periodic property is effective nuclear charge. It is a measure of the ability of protons in atoms' nucleus to attract the electron in orbit around the edge of the atom. It means whenever the proton which is present in the atom's nucleus, it is attracting the electron from its surrounding. So it will have some change in its orbit, in its shells. So that is nothing but a nuclear charge. So nuclear charge also changes when we move across to the period. When we move across the period, this nuclear charge changes. The effective nuclear charge increases period since number of protons increases. So as we move down the group, as we move down the as we move across the period, this protons increases, the number of protons increases, which means the effective nuclear charge will also increase. On the other hand, when we move down the group, when we move down the group, when we move down the group, the effective nuclear charge decreases. Okay. So when we move across the period, the effective nuclear charge will increase. But as we move down the group, this effective nuclear charge will decrease. Because the number of shell increases, it means that the holding capacity or the attracting power has loosened. But if the electronic shell was the smaller as compared to the bigger, it means the electrons are pulled mostly toward the center. Okay, so it means that it will have the effective nuclear charge. But if the electronic shell will increase, the holding power of the proton will loosen. That's why the when we move down towards the group and as the number of shell increases, the effective nuclear charge will also decrease. Now, periodic trends in relation to the nuclear charge, the atomic size generally decreases as you move across the period. Now, the shell has increases, but atomic size has decreases. Consequently, atomic size increase as you move down the group. Atomic size increases. Okay, we have already seen that since the atomic shell are increasing, okay, electronic shells kept on increasing, so effective nuclear charge was decreasing, but the size is getting increases. So as you move down the group, the atomic size will increase, but as you move towards the across the period, the atomic size decreases. Here we have seen that atomic nuclear charge has increases, but this size which is at which we see here, it will decrease and not increase. It will move, it will increase as we move down towards the group. Now periodic trends. As you descend the group 1, the reactivity of the elements increases. As you move downwards from the group, we can see here like the hydrogen, lithium, sodium, calcium. So as we descend, as we move down from the group 1, the the reactivity of the elements will be increasing, and this is due to the part of increasing nuclear charge. As the attracting power of the proton are increasing, the nuclear charge is increasing, which means the element will react more. Okay, and group 18 is also called as noble gases. They are very stable. due to the filled valence shells and are less likely to react with the other element. Why they are called as a noble gas? Because we know that noble peoples do not, they live separately and they do not combine with the other peoples very easily. So similarly, these elements which are placed at a group 18, they do not react very easily and they have the valence shell. It means they are very stable. And if something which is very stable, it won't find it easy to lose or to gain something. Why it would gain if it is already stable? So that's why these are called as noble gases. It is placed into the group 18. Okay. The example of these are helium, neon, argon, krypton, xenon, radon. Okay. So these were the example of noble gases. Now patterns and prediction. Already which we have seen, atomic radius trains in the period from left to right, atomic radius will decrease. Okay, atomic size will decrease because nuclear charge has increased and electrons are pulled together. That's why the nuclear radius or the atomic size will be decreasing. The radius, which is already depend upon what atomic size, so atomic radius will kept on decreasing as we move from left to right. But as we see it from the top to bottom, it will keep on increasing. It will keep on increasing because new shells are added, and as the new shells are added, the atomic size has increased. Please consider it as an atomic shell. Okay, electronic shell. So as we move down the group, the atomic size has increases, which means the electronic pool, the protonic pool, the nuclear effective charge which was attracting this electron toward itself has decreases. That's why, so the atomic radius will be increasing. Now valency trend across the period. How does the valency changes? So it increases from 1 to 4, then decreases from 4 to 0. So as we move across the period, first it will be keep increasing from 1 to 4, then it will decrease from 4 to 0. But what if we move down the group? The valency will remain the same. The valency will remain the same. Now, metallic character, tendency to lose the electrons. Tendency to lose the electron. The metals are the electropositive and not electronegative. What does that mean? If something which is electropositive, the metallic character which was electropositive, it means it will gain the electron, it will lose the electron and it will have the positive charge on itself. And what does we see, what trend do we see as for the metallic character? So it increases down the group, increases down the group. The metallic characteristics, it means the tendency to lose the electron, uh, it will increase down the group and decrease across the period. And non-metallic group, non-metallic character, it means tendency to gain the electron. That's why the non-metallic elements are also called as electronegative elements. So what trend do we see here? That it will decrease down the group and increase across a period. Tendency to gain the electrons. Now gradation in the halogen family. Halogen family again, which we have seen in the um, okay. So for the halogen family, which are the fluorine, chlorine, bromine, iodine. So these have the characteristics which are the non-metals. They are the non-metals. They have the valency 1. They exist as a diatomic molecule. Diatomic, it means they exist in the F2 fluorine, which will have the two atoms in its shell. Okay, and the chlorine too. They are highly reactive. They form salts, which we known as halides. Their atomic size increases down the group. Why does it? Why does? What is the reason behind that? Because the addition of new shells, and because what about the electronegativity um, or the non-metallic character? That it decreases down the group. Fluorine is most electronegative element. It means is the reactivity decreases as we move down the group. Okay, so it's a wrap again, guys. We have seen about the Dmitriev Mendeleev. So he was the first one who has produced the practical periodic table. His work became the basis of the modern periodic table. It has vertical column, which we called as a group, and the horizontal periods or horizontal rows, which we called as the periods. So vertical column were the groups, and horizontal rows were the period. Its arrangement allows us to look for the patterns in the properties for the elements. Okay, so I hope all the concepts are clear to you. If you have any doubts, please let me know in the comment box. And today we are also going to do the next chapter. So see you guys again. Bye bye.